Today, the Retro Rack is getting some much needed climate monitoring via an IT Watchdogs WxGoos-1, aka the Weathergoose. This thing can monitor temperature, airflow, humidity, water intrusion, and much more. We'll take a look at a few remote sensors you can plug into this thing, explore its beautiful mid-2000s web UI, and finally fire up a Windows 2000 server running IIS. Because we're going to figure out how to take the XML sensor information the Weathergoose can spit out and turn it into something the Cisco phone can display. So dust off your FTP server, because today we're becoming Microsoft ASP backend developers. Let's get into it. This is a server room climate monitoring device, so things like temperature, water intrusion, a bunch of other stuff from the mid-2000s. It was manufactured by IT Watchdogs Incorporated. My particular model is the WxGoos-1, aka the Weathergoose. You'll notice that geese are a big deal for these IT Watchdogs people. They also had the Weathergoose 2 and the SuperGoose 2, and let me tell you, they did not skimp on the graphic design for the front page of that manual. Now, I did a video on this over 2 years ago, believe it or not. I powered it up, I got it working. It's got a cool little web UI, and we should be able to communicate with it. I know it's functioning, but it didn't have any sensors. However, it does have a ton of internal sensors. So with no accessories, it claims it can do temperature, humidity, airflow, some I/O ports, light detection, and sound level detection. So the plan with this thing has always been to get it over in the room with the servers, where I'm hosting the Retro Rack as well as my home lab, and get it at least measuring temperature. But I also have some sensors. About 2 years ago, a viewer named Maggie sent me a bunch of sensors and another device. Let me pull all this out. Pile of sensors we're going to look at, and then this cute little guy. This is a WxGoos-3, aka the MiniGoose. I think back in the day you can pick this thing up for like $200 US, mid-2000s, and then the bigger geese were something like $400 or $500. Looks like this guy also has a web server of some type, internal temperature sensor, and you can somehow connect 16 additional sensors up to it. On one end it's just got the Ethernet network port. On the other end it's got a barrel jack for power, a connector for sensors, and I believe this must be the temperature sensor, somewhat precariously sticking out there. We'll boot this one up, see if it works, but our main goal and focus is going to be using this one, racking it up, maybe plugging some of these additional sensors into it. I believe what we're looking at, based on a note from Maggie, is this is an airflow and temperature sensor. That's pretty sweet. This one is just temperature, I'm guessing. Probably not enough equipment in there to detect airflow. And then we've got a water sensor. This is the only one I'm super sure of because it says it literally on the thing. And then I sat thinking about this one for a really long time. Like, what am I looking at here? It's got these tubes, and they're like daisy chained. So this one has a 6-volt DC power adapter on one end, and that makes its way into this tube, which then turns into our little connector that goes into the Goose. And this one looks pretty much identical. So I think this is somehow temperature, airflow, and power detection. Like it can tell if there's power coming in for some reason. I don't quite understand that. We might not be messing with this one. But the idea here, of course, is in addition to the onboard temperature sensor, we could slap this in, run it to a different part of the room, even though that room's pretty small. Maybe we could put this like in a server if we really wanted to. That could be cool. I'm always interested in the history of the gear I pick up, especially enterprise stuff. And I bought this one on eBay for like 35 bucks or something. And its full configuration was still on there. Administrator emails, everything. It belonged to a British engineering firm called Atkins. So that was pretty cool to see in there. I go over that in the old video if you want to check that out. And then all of this stuff came out of Harvard. It was in a engineering, physics, computing lab type setup. And I actually know where all this stuff came from. So thanks again to Maggie. First things first, let's talk about how you actually administer these things. So there's no serial port, as you can see. There's just the 10100 Ethernet port, and it hosts a web UI. And by default, it'll be at 192.168.123.123. I've never actually found the user manual for this WxGoos-1. I've been basing all of my research and information off of that beautiful Weathergoose 2 and SuperGoose 2 manual. But oddly enough, it actually points out differences. So it claims that this old WxGoos-1 always hosts on that default IP even if you set another one. I don't recall that from the original video, but we'll give that a shot. And another problem is on the newer Geese, there's reset pins. So you can factory reset them if you physically have access to the device. And as you can see, this one does not have that. So I'm just redocumenting all this for posterity, but even if you know the IP address, you might not know the administrator username and password, and there's no reset switch, so what do? Back when I covered this thing, there was an ancient YouTube video, and by random coincidence, some guy relatively recently explained that there's always a secret user on these things. The username is reset, and the password is powerup, followed by the last 4 digits of the serial number. 0052 in my case. So yeah, that's a wild ride. If I ever need to factory reset this and I can get into the web administration interface, I use the username reset and the password powerup0052. And that's how you can get into these things in case you find one in your hands that you don't know the password to. There is no mention of that in the Weathergoose 2 and SuperGoose 2 manual. Another oddity is they want 6 volts DC, which is kind of weird to have on hand. The MiniGoose also wants 6 volts DC, but in that manual for the newer versions it says 6 to 12 volts is fine. And the power adapter Maggie included was also 12 volts, and I don't remember what I did the first time I powered this on. I suspect it can take 12 volts, but I do have I scrounged up a 5 volt adapter. So let's see if we can get into this thing. We'll start with the 5 volts. We'll see what it thinks about 5 volts. There is a power LED indicator. Yeah, it's on. Green down there now. So what we're doing here is we're going to reconfigure the IP on this thing to be in the retro rack. That's a 10000 network, and I have what I believe is a crossover cable adapter here. I should probably label this thing. Pretty sure that's what it is. So we don't need a switch, we can just direct connect over to here. I'm going to try that 192.168.123.123 default network thing. The manual says that that will always be available. That network has what they call a backup. I don't recall doing that previously. I know for a fact this thing has an IP that is not on that network. So let's see if that works. Okay, so we'll get this thing on 192.168.123. We'll give this IP 100. Try pinging the Weathergoose. Oh. Too many numbers. Oh. I don't remember this from last time. Probably didn't read that manual. Well. There's the Weathergoose asking for a username and password. I think it was administrator, and this was before my very safe, consistent retro rack naming convention of my wife's name as the password. Probably Clab Retro. Oh, maybe it is my wife's name. It was. Works every time. So yeah, here's the Weathergoose. I don't want to get you too excited. We'll get this thing racked up next, I think. So its original IP address was 10.240.3910, and this Phoenix server room thing was from the original configuration. And it wants you to have an admin context, so I'm clabretro@atkinsglobal.com. Let's see, let's get this on the RetroRack network. That's a 10000 network. Yeah, the old NTP server from Atkins. The mail server from Atkins was all configured. Pretty wild. Okay, what do we want this thing to be? Let's consult the list. I keep a Google Sheet of all the items that are in the RetroRack, their IP. For a brief time, I was keeping track of what switch port they're plugged into. The machine, this is usually the host name, but sometimes just a human-friendly name for me. The PDU port they are plugged into. I'll talk about that in a little bit. This is how everything gets power, and I can remotely power things on. And then the terminal server port that they may or may not be using. And it looks to me like we've got a little bit of a gap that we can leverage. This thing is going to be, the Weathergoose is going to be 30. Give it its full proper name, the WxGoos-1. And then we're going to assign it a port, and I know, let's see what ports are open. I've got a 16 port PDU that I can control over SNMP, which we might have to deal with later in this video. And it looks like outlet 7 is available. So we'll use that. I'm running out of outlets. Is that my last one? That's my last free outlet. So we're going to have to start getting some splitters. I'll talk about that later after we rack this thing up. So we're going to assign that outlet 7. I haven't done any of this physical work yet. I'm just planning ahead. On a previous video, someone commented and made a pretty astute observation, which is I hard code all my configuration. When any computer needs to talk to another one, I'm using their IPs. And my first 100 IPs are reserved, so the DHCP server won't give them out in the retro rack. And ideally, I should be using DNS, because that's the whole point. I should be able to call this Weathergoose-1 with a DNS server and resolve it to whatever IP it ends up being at the end of the day. But in my particular setup, I don't turn all this stuff on at one time. So, for example, I've got a really big compact DL380 Gen 2 running Windows 2000. It is already a DNS server for some Windows stuff. It would be a perfect candidate, but I don't want to power that thing on when I want to look at my Weathergoose information. So I think what I'm probably going to do eventually is cheat a little bit. I'll have a Raspberry Pi that is actually the DNS server, something really low power that's always on, so I don't care about turning it on and off. I don't leave this stuff on 24/7. My biggest fear is that it's going to wear out. So it's all this gear is getting up there in age, as we all are. And I want it to work as long as possible without having to repair it. So running it 24/7 when I'm not using it doesn't make sense. Also, it's expensive, especially big era-appropriate servers that would have been DNS servers back then. It just doesn't make sense to run those all the time or power those on when I need to do something totally superfluous to that item. So that's a little window into how I'm thinking about this at the moment. So all of that is to say, we're going to make this thing 10.0030, right, Chloe? And we'll save those changes. Interesting, it says it's going to restart automatically in 60 seconds. But it's actually going to be way faster than that. It's going in the rack. Well, I've got the Windows 7 laptop out and it's easy to deal with. Let's power this thing on and see if it's at its default IP as well, since this is already on that network. Maggie was saying it was probably already factory reset. Of course, it doesn't have a factory reset button. What does it smell like? Nasty Harvard engineers. So this thing is quite hefty. Obviously, it's larger, but very high quality metal. And this thing is very thin metal, weighs next to nothing. Let's see if we can see it on the browser. Oh yeah, working perfectly. This is the, well, technically it's the WxGoos-1 trademark, but everyone called it the MiniGoose, including IT Watchdogs. Wow, yeah. Looks like it's factory reset. It thinks it's 72 degrees in here, which is probably roughly accurate. I think this guy was saying it was 71. Oh, and then look what Maggie did forever ago. Hey, Colby at collabretro.com. I love that. Thank you, Maggie. That's hilarious. Yeah, cool. Thing looks great. All I really want is one temperature reading. I have half a mind just to slap this thing on the rack with a zip tie and call it a day, but nope. We're going to go all in. We're going to get this mounted up. One last thing before this is physically inaccessible to film, as you'll see. While I was complaining that this is clearly a lower quality product in terms of its production components, I'm not saying it necessarily doesn't work well. This one is super hefty for being a 1U item. You can just tell that metal is no joke. I will say though, they used the same sticker material on each of them. I like that. And it tells you pretty much everything you need to know. Now, I of course haven't ran these in production. I think Maggie had good things to say. I think they bought a bunch of Weathergoose 2s and SuperGoose, maybe even SuperGoose 2s or something for the lab. Everything about this IT Watchdogs thing strikes me as like, this is going to sound bad at first, but like not professional or like amateur. Like that documentation, it was very approachable. It wasn't very rigid like a Cisco piece of documentation, which would have been spread out over 3 800-page PDFs. They were telling you all the differences between this version and the Weathergoose 2. Those highlights actually are in the PDF manual for the newer versions. And I don't know. My point is, it strikes me as a company that was small but really cared about what they were building. I can't prove this. and again, it's not like I'm running these in production, but you could tell like some care and some thought and some love went into it, is all I'm saying. Let's get this thing racked up. So I was thinking through physically where I want to put this in the retro rack and how I'm going to power it up, and I'm already realizing I've got some problems. The thing about the retro rack is built different. It's powered exclusively by 240 volt service going into a big ass 16 port PDU or power distribution unit on the back. And that PDU accepts one of these style cables that is rated for 240 volts. So this IEC connector, I can't remember the exact name. That plugs into the PDU, and then usually you'd plug this into a server or network appliance, no problem. But this thing takes this silly little wall wart power adapter. Could we? Could we? I'm just kidding. I'm not going to do that. But you can get adapters to go from here to here. No problem. I just got to order one on Amazon. Maybe it'll be here by the end of the video, but I don't have one right now. I should also note, it's very important, this thing can take 100 to 240 volts AC, so this guy's no problem. He can handle that. So I'm thinking, like, do I want to extend 120 volts over to the retro rack? Let's go in there and have a conversation. So here we are with the retro rack. This is the main networking area here. So this big router provides the network that the Weathergoose is ultimately going to be plugged into through one of these switches here. This whole thing is 240 volts with that PDU I was showing you on the back, but it wasn't always that way. Up there is a simple little switch on deal, but that's 120 volts. I don't think I need 120 volts in this rack. And so I think what we're going to do is put the Weathergoose way up there. So I'm going to pull that out. I've been hesitant to do this because I have this light up here. It's not plugged into anything right now. And it's really nice when that's turned on, actually. The film quality is much better. And I can see better. But I think we're going to take this thing out. We're going to put the Weathergoose in its place. And then I've still got 4U right here. A U is a rack unit. This thing is a 1U item. So is the Weathergoose. Yeah, I think we're going to put the Weathergoose right here. Hot air rises, we'll get the temperature from the internal sensor, plus we can run the other ones anywhere we want. Yeah, I think this is the path we're going to take, and we'll put an extension cord in for now to power it off of 120. It's in there. I really like these metal cable management things they gave you. So we've got power, network. Oh, this bolt is also being used as a cable management guide. And I made the executive decision of putting just 2 bolts in. This thing weighs nothing. And that made it so that I could put it really high. I could push it way higher than it would be if I had all 4 bolts in. God damn it. There we go. And that is because, I don't know if you can tell, but this bolt is already getting in the way of these. And that's because the VXR below all that stuff is on a universal rail kit, meaning it's just a little shelf. And it takes up an awful lot of room and pushes everything in a bad way. It's no good. But yeah, the Goose is up here and it's looking pretty good. It'd be really nice. It's not going to make it into a lot of shots. I'm kind of disappointed. It'd be really cool to have it like right here because I think it's a really cool looking device, but it just doesn't make sense to have it intermingled. And I didn't have room anyway. And it kind of makes sense to have the temperature at the top. It's like the worst case scenario, right? This is my home lab rack just to the left of the retro rack, and it's got a really nice 120 volt PDU down there. So I plugged the Weathergoose into this. And you know, it's a pretty professional setup. We got this piece of crap Belkin power strip. That's the Weathergoose right there. And this white cord is the light on the top I was just showing you. And it's acting as strain relief for the wall wart. So, you know, that's good. It's really nice to be able to turn on that light again. So when I switched this whole rack over to 240 volts, couldn't plug that in to the rack. So now it's plugged in. I know I always say this, but I just bought a ton of different adapters to get the Weathergoose plugged into the proper PDU. So they're going to arrive in 1 or 2 days, hopefully in time for this video, and I'll show you how I fix everything up. But for now, the Weathergoose is on. Well, let's power up the rest of the rack. That blue cable way up there is going into one of these switches. We'll see if we can talk to it and see the ambient temperature. So my guess at the moment is that it's about 75 degrees in here. And that's just with my home lab rack that is always running. So a couple servers, UNAS Pro, bunch of switches and stuff. I also have another light in here, which I use for filming, but I always forget to turn off. Theoretically, the Weathergoose can detect light. So it'll know like if the main light's off, if I left those on. I think I'm sort of tempted to leave the Weathergoose on all the time and be able to look at it on my phone. I think that'd be pretty cool. But for now, this is the setup. The retro rack is growing up. We're gonna know its temperature very soon. Let's go power all this stuff on in the other room. And right away, once the network is available, we'll see the temperature and see if all these switches add to the heat. When I say all this stuff, I'm not actually talking about the servers. We'll run some experiments later because those servers add a lot of heat. The network gear just adds noise, basically. So let's see. A typical interaction with the retro rack is turning on all the network gear. So terminal server, the router, the aggregation switch, the main switch, another switch, and we don't actually need to turn on the phone router for now. This is a Windows XP VM running in my home lab rack, and it usually takes a couple minutes for everything to truly come online. This is moments after I powered everything up. And yeah, we can't even see the router yet. So I'll wait a couple minutes and then we'll try to get in really quick to the Weathergoose and we'll see if the temperature rises as that Cisco gear heats up. All right, it hasn't been very long and we can see the router. Can we see the Weathergoose? We can. Let's get in there quickly. All right, it's asking us to log in. Okay, it is 79 degrees Fahrenheit in there. That's pretty warm. Later in the video, I want to programmatically learn about this temperature. And I'm hoping I don't have to do it over SNMP, but I'm pretty sure I'm going to have to. It is running really slowly. Ooh, yeah. So hopefully I can call this from like an API. That would be nice. Look at all this stuff. Let's see. This is an Ubuntu VM that has access to the RetroRack network, and I can get a ping response, but I'm imagining this is going to require user and pass. Yeah, auth failed. That's actually interesting. Maybe we can do something with that. All right, I was actually pretty encouraged that it just said authorization failed. So what I'm going to do is just basic HTTP header auth, and so the username is administrator and the password is my wife's name 123. Oh, no way. So we definitely, it is returning that XML. We can automate this. We can definitely return a lot of stuff. We can definitely automate this. This is really exciting. So what just happened there is I was able to remotely, with the username and password, get the same information. So in devices, we've got temp Fahrenheit, and the Fahrenheit value, it is 26 degrees Celsius in there, and it does have an airflow going on. And I was reading in the documentation that light, so it's got the light sensor, this is relative to the value 20, or maybe that was airflow. Well, anyway, I'm going to go turn all the lights off, and we're going to refresh this page and see what we get. Right now, it's at 72, and it's got a min value of 1, max value of 100. I just went in that room and turned all the lights off. It's completely dark in there. When the lights were on, the light value was 72. Let's refresh. And now it's 1. So it's all relative to whatever this, it's not like calibrated to anything specifically, but the point is, when I see a 1 here, I know all the lights are off, and when I see basically anything significantly higher than that, I know the lights are on. So I can tell the lights are on or off now. This is really exciting. And because basic auth works, we're just gonna grep for the word light. And sure enough, I'm getting XML back. Well, it's the same thing I was just showing you on Internet Explorer with a value 1.0. I'm gonna go turn the lights back on. I'll be back. Okay. All the lights are back on. The old level was 1. What I'm doing here is I'm hitting that XML endpoint and I'm doing something called, oh, you can't see it, grep. So I'm searching for the word uppercase light. That's all I'm doing. And we're going to do it again. And the value is 91. The main light was actually off when I was getting that 70 value. So this Weathergoose is working really good. This is good. Let's go back to the web UI. We got the sound level too. That should go down when all the Cisco stuff's off, I think. Right, buddy? Right, buddy? So this is very exciting. This means I can programmatically interact with this thing. You'll see why that's important later. Yeah, and right here, of course, I get the same information. I've got light level 91. It's kind of surprised it's 20% humidity in there. I live in Colorado and it's usually like, oh, maybe that's normal. I don't know. So if you've ever wondered, it's 79 degrees Fahrenheit in the retro rack room with all the network gear running and my home lab running. And we'll be able to convert this later, but the XML gives you everything. 26 degrees centigrade. The Weathergoose is already useful as is. I can tell the temperature in that room over there. But I believe what I have here is a individual temperature sensor. And here I have a temperature and airflow sensor. So let's plug these in and figure out something interesting to do with them. The current setup is, I believe, what I have is just the temperature sensor, that thing with not much going on the end, plugged into this port, and then a airflow / temperature sensor, I believe that's what this is, plugged into this one. This one is going around to the back of the rack. It is positioned behind this absolute furnace, this compact DL380 Gen 2, running Windows 2000. This guy, we'll plug him in later. Of course, the whole thing isn't ideal. The cables are just draped off the front of the rack there, but we'll fix that eventually. And then for science, the one that is just the temperature sensor is going out the door. It's much colder over there. You can see the cables moving because Chloe is on the other side of the door. Let me see. She's not allowed to come in here for obvious reasons. There's a lot going on in here. Let me see if I can settle this down. Chloe, can you not? Now that I'm back in the workshop, Chloe has no interest in that cable she was messing with on the other side of the door. It's poking out just enough to be away from the servers. And down here, the furnace, the AC, everything is off. It's been kind of cold lately. And it says it's 69 degrees Fahrenheit. And yes, it doesn't know the time and date. I don't care about that. Back on the UI for the Weathergoose, the temperature has creeped up. 81.54 degrees Fahrenheit. And that's because the retro rack is on now. So the ambient temperature in there without the retro rack is probably like 79, and now it's 81. And then down here, I didn't refresh this page. I like literally live plugged in those sensors and this thing came to life, which is great. And the temperature sensor that is poking out the door that Chloe was messing with says it's 66.88, and that's pretty good. I think that's pretty accurate. And then at the bottom, we've got airflow 15, and it even has an alt value, relative value, comparable. So I'll show you the docs later, but I think it said a value of 20 means next to no airflow. And then once there is airflow, it's all relative to that. So like 40 would be more than no airflow. I think that's what it's trying to say. And behind that compact, it says it's 79 degrees Fahrenheit, which more or less adds up. It's probably warmer at the top of the rack at 81. Not bad. It's the next evening, and it is quite a bit cooler in the server room today. 76 degrees Fahrenheit. The airflow sensor is still in the same place behind that compact. I don't know why it's getting 24 airflows instead of 15 from yesterday. And then you'll see the temperature sensor is quite high, 96.8 degrees Fahrenheit. I stuck that behind the home lab servers just for fun. It doesn't feel like that when you have your hand back there, but I'm actually kind of shocked to see how warm that is. So the last little test we're going to run before we start doing some app development is this airflow sensor. I'm going to power up that compact. I'll come back when it's at full tilt running Windows 2000, and we'll see what we see. That server's on, blowing tons of air past that sensor, and it says the airflow has gone down from when the server was off. So I don't really care about it anyway, but yeah, maybe I'm doing something wrong. I do expect an increase in this temperature though, over time. We're actually going to use that server for the rest of this video, so it's going to be on for a long time. We'll be able to come back and take a look. I'm also kind of bummed out that my graphs don't work for the sensors. It is time to retire the Phoenix server room and rename it to the retro rack. I'll keep my Atkins Global contact email though, just for fun. I also had to change it over here, the name of the internal sensors device to retro rack, and then it starts updating in the upper left here and hopefully here. Yes, we now have a device with name retro rack. We'll use that later. And I guess I didn't look at this. Here's the airflow sensor and the other temperature sensor. So pretty logical. They just show up as extra devices. Let's do some back-end development, year 2000 style. Getting Windows 2000 started up here. And you can see the Cisco phone is back out. If you caught the last video, I got these all customized with sweet background wallpapers. And there's this services button. Once the Windows 2000 machine is fully booted, it's hosting what Cisco called IP phone services. And they are dynamic ASP backend server pages written in JavaScript in my case, or at least those are the examples Cisco gave. And we're going to write another one ourselves. And I want to be able to come in here and view temperature information about the retro rack from my Cisco phone. So this Windows 2000 machine is running IIS, a web server, and it's hosting this IP phones folder. And at the root, the phones have been configured to grab this menu.xml, and I'm listing two services, one called clock and one called measurement. Let me show you clock. So in the clock folder, there's a single ASP file, and this thing is a bunch of server-side JavaScript, and at the end of the day, it is serving some XML that the phone understands. So now that this is up, let's go look at that on the phone. So if I go to services, CME service URL, there's my menu.xml that's listing these two options. I click the clock, and it dynamically grabs it from the server. The server thinks it's 7:47 p.m. right now. So same idea. We're going to add one called retro rack or something, and it's going to spit back the temperature. Couple hurdles. First, I need to learn how to write these ASP scripts. I don't think it's going to be too hard, but there's two relatively advanced things to do. We need to make a request to the Weathergoose, and we also need to parse its XML in return. And then the next hurdle will be, what XML do I need to produce to make the Cisco able to display something useful? I don't think it's going to be too bad, but I'm not going to develop it directly on here. I suppose I could. We're going to do it pro style, the way you would have back in the day. I'm in here managing IIS, which stands for Internet Information Services. And I want to set up an FTP site so that I can, I don't know, let's see if this works. IP phones FTP. The server is hosting this IP phones folder. I'm also going to set up that thing with FTP access. Definitely read and write. Okay, see if that worked. It did work, so if we FTP to it, you can see it's coming back Microsoft FTP service. And I am administrator. I think you would normally, well, I know you would normally make different users and passwords for this. But I'm in a home lab. So this part's kind of weird. I'm able to log in, but ls-dir shows me nothing. I remember I called this FTP virtual directory thing IP phones FTP. Well, you just blindly go to cd IP phones FTP, and there's all my stuff. So we're gonna make dir, let's call it Weathergoose. Oh yeah. Long story short, we're gonna develop it on this machine so I could sit at this computer. We're gonna FTP stuff over there and test, and that'll be that. So for example, I think if we curl this clock.asp, we'll see what the phones are getting back. Yeah, there you go. A bunch of XML and this binary blob stuff to actually show the clock segments. I'm gonna go learn ASP. I think the first thing we're gonna do is write the simplest Cisco services app we can. And it's gonna be something that just shows text with this Cisco IP phone text thing. I just did a bunch of stuff and I wasn't recording it. So let me catch you up. I'm using the FTP server so that I can transfer files over here, edit them, push them back up and test. So I'm pulling down the menu.xml list, and we're gonna go in here and edit menu.xml. We're gonna add a new item, and instead of Weathergoose, I'm gonna call it retro rack. So this is gonna be a all things retro rack app, I guess. So retrorack.asp. We need to make this folder and put that file in it. So let's make a retro rack folder on the website. I think this is like the simplest Cisco IP phone services app I can make. So this is my retrorack.asp file. I'm telling the server I'm going to write this stuff in JavaScript. You have access to this response object. Basically, you can set metadata about how the server should respond. So I'm setting the content type to XML. And this is interesting. That clock that I was showing you, it actually refreshes itself every once in a while. And I noticed this in the clock example code. So they're adding this refresh header, and it must be coming back every 15 seconds or something to refresh. We can leave that here. And then I believe this is just going to show some text on the screen for the phone. So I have this retro rack info and some placeholder text about information about the retro rack. And I just got those files on there. So my updated menu XML, I'm just using FTP to push it up there, and this retro rack thing. Let's see if the server can serve our ASP file. That looks pretty good to me. It made some XML for us. Let's see what the phone thinks about this. Back on the phone, in my experience, you don't need to reset the phone or anything. It dynamically grabs that menu XML every time you enter this menu item. At least my setup's doing that. So yeah, we already have retro rack. Wonder what that stuff looks like. Nice, retro rack info, title, and some text. We could definitely put some temperature information in there. I like it. What's update do? Oh, it just forces a refresh of the app. Cool. All right, now we need to make an API call to the Weathergoose from my ASP script and then parse the XML that comes back. As you'll recall, we are able to make an HTTP call to the Weathergoose to get data.xml, and we're using basic header authentication. So behind the scenes, curl is base64 encoding this, I think. That's what this .u, and the way this basic header auth works, it's the username, a colon, followed by the password. So we need to replicate this whole operation in JavaScript on the ASP server, and then we're going to figure out how to parse this stuff. Of course, we could use regular expressions, but I have to imagine that ASP and Microsoft had an XML parser you could use. You ready for some good old-fashioned crappy code? So what's happening here? Best I can tell with Googling, I think there's several ways to make a HTTP request, but I'm using good old XML HTTP, and so I do this server create object thing. There are many objects you can create. We're going to make another one to parse the XML. I haven't tried this yet. And then I've got the Weathergoose endpoint. I've got the user and pass. You call open on the XML HTTP object, and theoretically, I can pass user and pass, and it will do the basic header auth. I might need to encode this myself and set it as a header specifically. We'll see what the Weathergoose has to say. And then we send it off, and if it was an okay response, I guess I didn't check what the Weathergoose was giving back, probably 200. I'm just dumping it right out to the screen, and then if it fails, this is some forward-looking stuff on my part, I'm going to write one of those Cisco IP phone text things with the error information so the phone can understand it. Now, normally I think you'd wrap all this in a try-catch and handle it that way, but we're just gonna let it rip. Let's put our latest retrorack.asp on the server. Now, I know there's many ways to do this, but I can guarantee you this is how a lot of development happened back in the day. Even as late as the late 2000s, I mean, this is how you would do a lot of development. Maybe you were going to a staging server, but there's better ways to do this, of course, but I'm just doing this for nostalgia's sake. All right, are we gonna crash the IIS server? Oh yeah, it didn't like that. Invalid prog ID. I need to Google, well, I'll tell you what that means first. It doesn't like this object I'm creating. It doesn't know what this is. So I will go find another way to do this. Kind of hard to find information on this stuff because it's just not in use any, well, I shouldn't say that, but it's sort of been wiped from the internet, and then they called ASP has successors and stuff, which complicates things, but I was able to create a new ActiveX object called Microsoft.xml HTTP, and check it out. Got that on the server, and I think it worked. This is Weathergoose stuff coming back. Looks like crap, of course, because we've got to parse it and do something with it, but I think I saw way at the top. There it is. Here is our sensor data. So we can parse this. It is 82 degrees Fahrenheit in there right now, and the Windows 2000 server just told us that. All that being said, some of this stuff is still hosted on Microsoft's website. So hopefully we can create this ActiveX object. It's of course called mxml2.dom-document.6.0. I don't know if my version of Windows 2000 has this. You can load directly from file, but we are going to load from the string that came in from the Weathergoose. And then we can start doing some XPath stuff. I'll show you what I come up with. It didn't like that. So line 18, I'm trying to make that DOM parser thing. And the server says, automation server can't create object, line 18. So I got to read some more docs. Trying this older example, Microsoft.xml DOM, which at least from a naming perspective is very similar to Microsoft.xml HTTP, and it says object expected. Let's go see what these error pages look like. Oh yeah, everyone remember these? Oh, and it does refresh every 15 seconds. That part works. Yeah. Object expected, huh? Well, I fixed it. Instead of create object, I just called new ActiveX object. And now it is grabbing the information from the Weathergoose and not actually doing anything with it at the moment. I got to learn how to use this Microsoft XML DOM parser so that I can traverse into the XML. Remember, it looks something like this. So I need to traverse into the devices list and grab the device node with name equals retrorack. And then I want to extract temp C and temp F values. I will go figure out how to do that. I do want to show you a Stack Overflow classic post. In 2012, someone's asking, does server.createObject use ActiveX? So you'll notice I couldn't use server.createObject in my current setup. I had to use this ActiveX function. And I like this guy. ActiveX is just some marketing spin for COM components. Putting X on the end of words back then is the same as putting I at the start of words today. Windows development is such a zoo. We're going to parse this XML. I'm looking at Microsoft JScript runtime type mismatch. Oh boy. I think we're cooking. So to refresh your memory, this is the XML we're parsing. It's got a top level server, then a list of devices, then each device. I care about a device called retrorack, so a device with a name attribute of retrorack. Within this device are these field elements. They have a key and a value. The two I care about are key equals temp C and key equals temp F. So with that in mind, let me attempt to show you what I did. I'll put this up here, I guess. On line 18, I'm creating a Microsoft.xml DOM, and then I'm loading it with the XML that we requested from the Weathergoose. So that's what's in the upper right there. Then I am diving in with something called XPath. So what's happening here is it says, look anywhere in the document for device elements. Give me the one with attribute name equals retrorack. Go deeper into there and give me a field element with the key equals temp C. And I am shocked. I was able to do this from memory. I didn't really have to Google that. XPath stuff used to do it a lot back in the day. So that XPath that I'll put on the screen here is giving us temp C, I think. And then it has a value attribute, and that's the actual temperature we care about. Oops, I had a different name for that. So there we go. So what do we got going on here? It's going to go try to find temp C. If my XPath is wrong, temp C will be null, and it'll fall into this temp C is null print. Otherwise, it's going to go retrieve the value attribute, which should be the actual temperature. And check this out. Look how fast I was getting at this dev turnaround time. Go throw it on the server, curl my test, bam. Okay, we got 29.25. Is that correct? Refresh this here. It is. Temp C is 29.25. We are cooking. We're almost there, I promise. I'm going to take away all of my error handling. We need temp F as well. There's probably more clever ways to do this, but we'll go dive into the key equals temp F. And now we actually get to do something cool. Let's just call it temp F and temp C. I need to go look up how to intersperse values into this stuff with ASP. It's pretty similar to PHP, so you use this special tag, and I think we can say temp f.get attribute value. I don't know if I can call functions inline like that, but we're about to find out. And temp C will be something very similar. Temp c.get attribute value. Okay, get it on the server, do a test, bam. Script block lacks the close of script tag. Oh, I can fix that. That was actually a very good error message because it was completely accurate. What's going to happen? JS script compilation. Expected at a parenthesis. Did you though? I don't believe it. I think I got it. Remember how I was worried about calling that function? Maybe there's a way to do this, but so I'm setting a new variable, C value here and F value, and I'm just spitting them out here in the XML. And check this out. I think we wrote our very first app that does something. Yes, this should theoretically show up on the phone. I think we've done it. If you don't like the command line, this is what it looks like right in the browser. And I'm not sure why IE is deciding to parse this XML and present it nicely. There, it just did its little refresh so you could, I don't know, have this up in a browser anyway. It's definitely XML, but it decided to take this. And it's shifting the title tag up to here, even though this is like obviously not a well-formed HTML document, but title is a legitimate tag. It goes in the head. The moment has finally come. Retro rack. I mean, yeah, there you go. Now I know exactly how warm it is in the retro rack room. From Chloe's phone here. That's Chloe, if you didn't know. This whole experience has really taken me back. I had a professor in college whose entire website was XML files, and he would run transforms on them like dynamically and serve the web page. Anyway, I've been thinking about why it is just displaying this. And I think it's because it thinks it's HTML and it's doing its very best to present it as HTML. It's doing a pretty damn good job, I must say. Here's that menu XML, and it gets, it displays it in this nice XML browser. And so I thought for sure, oh, maybe I had put a doc type on here, but I didn't. I'm guessing this version of IE sniffs out the extension, and maybe that overrides other behavior. What version of IE is this? Whoa. That's an old one. IE 6 was my nemesis. I remember trying to fix some like Mac IE 5.5 bugs, but I was definitely coming up in the web development game in college. Well, before college, in college, and then a little bit out of college. And you had to worry about IE 6. The web ecosystem is an absolute nightmare and joke right now, but it used to be worse. Well, I'm basically an expert ASP Classic backend server developer, and I know how to make Cisco IP phone services apps. I can't stress enough how big of an event this is. Totally changes the trajectory of my career. Jokes aside, I actually had a lot of fun doing this. This is something if you have like an asterisk server or any of the other PBXs that can run these Cisco phones, very easy. You don't have to have a compact DL380 Gen 2 running Windows 2000 to serve an XML to them and run these apps. So this is definitely very, very accessible and can be done essentially for free if you've already got the phones. I think this is just the beginning of the Retro Rack app. Right now it's reporting temperature, which I think is really cool. And I did actually get the cables, I think they're on my front porch right now, to fix up the power situation in there. Let me show you that. So remember the problem was I can plug this in the back of the PDU, that style connector, but all my cables were like this and I need to plug in a, standard North American plug style thing. Well, I bought one of these, so this can go in the back of the PDU and it splits it out to a plug the Weathergoose can use and a plug the other guys can use. And for future expansion, I bought some of these just adapters, so I can just turn it straight into that. And I also bought some splitters that plug into the PDU like this, but split out to just 2 of these. So the plan is, with all of that put together, I'm going to make it so that when the router is plugged in, the Weathergoose will also turn on, because presumably I'm not really doing anything interesting in there without the router. So I'll start sharing PDU outlets, because I've basically filled up all 16. But I think that's it for this one. Like I said, I had a lot of fun. We can do a lot of stuff in the future, so there's nothing stopping me from controlling those PDU outlets from the phone. That would be kind of weird because some stuff has to be on for that to be possible in the first place. And I don't think Chloe's ever snuck into an outro. Can you turn around? I hope you enjoyed following along. Please consider subscribing if you haven't. I am on the road to 100,000 subscribers, hopefully by the end of this year, if I can keep my act together and keep making videos. If you'd really like to support the channel, of course I'm on Patreon. I post the occasional early release, behind the scenes type videos, and what I'm tinkering on. You also get access to the Serial Port Discord, where I hang out quite a bit. Thanks again for watching. I hope you liked following along. I know it's tough when I'm just sitting there coding on the command line, but it's what it took to get this one done. We wrote our first Cisco IP phone services app. I'll catch you in the next video.